Let's start with the technique of integration by parts. Integration by parts says that the integral of u dv is equal to uv minus integral v du. The whole idea of this technique is to choose u and dv such that the integral of v du is easier to calculate than the original integral would have been. But how do you choose u and dv to make that true? Let's see this with an example. The integral of x cosine of x dx. To make our selection, we'll use the handy tool of Liate, L-I-A-T-E. Here, L stands for log, I stands for inverse trig, A stands for algebraic, T stands for trig, and E stands for exponential, referring to functions. So, which of our two functions here, x and cosine of x, comes first in the list? Well, neither of them is a log, so that one's out. Neither of them is an inverse trig. But oh, we have a winner for algebraic because x is an algebraic function. So we want to set u to x, since that one came first in our list. And then dv will just be whatever's left, which here is cosine of x dx. Now we'll find du, which is just dx. Pretty nice right there. And v, which is the integral of cosine of x dx, which will just be sine of x. We don't have to worry about the plus c here because that will be added on at the end of the whole integral calculation. For x is u, and the rest of this is dv. And we know this equals uv minus integral v du. So we just plug and chug. Our u is x, our v is sine of x, our v, once again, is sine of x, and our du is dx. So now we have x sine of x minus the integral of sine of x dx is just negative cosine of x. And of course, we have our plus c tagged on the end. So now we get x sine of x plus cosine of x plus c. And we're done!